Hey, this is Math 7, Unit 8, Lesson 11, Comparing Groups. Okay, so just as we start this lesson off, there are going to be a couple things we go through here that, for me, because I haven't done the 6th grade lessons yet, I found a little surprising. So just kind of keep in mind, this lesson has a lot of things it wants you to do that I'm not sure if you learned this in 6th grade or not, but it may be new. But it just gets a little complicated. So hang in there. We're going to take some good notes today, and hopefully you can keep these notes for things that come up later on in these units. In this unit, I'm just not sure. So we're going to talk about a few things today. We're going to talk about a measure of center. Now, a measure of center, when we talk about a measure of center, we're talking about kind of like what's in the middle of a group of data. And to do that, sometimes we use things like a mean or a median. And you recall those perhaps from 6th grade. And we'll take again a look at these as we go through. And we also talk about a measure of variability. Variability. Okay? And a measure of variability, and this is, you can find this in your summary statement, is something that's like the mean absolute deviation. Mean absolute deviation, also called or abbreviated as MAD, M-A-D. Okay, and sometimes you use what's called the interquartile range, which we won't get into that today. Okay, so these are some things that are going to come up today. So I had to do a little bit of research to see what exactly these were and how to present them to you. So just going to talk about these today as we go through it. So hang in there, take some good notes. Just know that there's only one problem in the homework that deals with any of this stuff, and it's just pretty general. So we'll see how this works out. So first of all, we have a what do you notice, what do you wonder activity, comparing the heights of a women's gymnastic team and the men's volleyball team. Okay, so you look at their heights here. What are some things you notice? What are some things you wonder? Now, one thing I notice is that for the women, they're all below 70 inches tall, right? Everyone is less than 70 inches tall. But for the men's basketball team, they are all greater than 70 inches tall. Just something you might notice there. You also might notice that there's no overlap, right? There's no overlap happening between these two heights. Like, you don't have a woman on the gymnastics team who's also as tall as anyone on the men's volleyball team. They are just different. There's no overlap. Sometimes with data you'll find an overlap. In this case, there isn't any. Okay, so the men seem to be significantly taller than the women's gymnastics team. The women's gymnastics team has a little bit bigger spread from 56 to 69, whereas the men are a little closer together, 72 to 81. So that's a spread of about 9. This is a spread of about, let's see, 10, 11, 12, 13. So the range of heights is 13 inches here, and the range of heights is about 9 inches there. So that's a little difference you might see. Okay, let's move into today's activities. Here we go. So first of all, looking at the same data set, but now with numbers, how much taller is the volleyball team than the gymnastics team? All right, so we want to look at these data points and decide how much taller is the one than the other. Now, that's not really very specific in terms of how much taller. You could be comparing a couple things. We could compare the total heights. We can add these up and then divide by the number, add them up and see, and just subtract the total heights there. You could also find the averages and then subtract the difference there, right? A couple different things. You could also find the middle height. So let's do both ways. Let's look first of all at the total height. Okay, so we talked about the total difference between these heights here. Okay, the gymnastics team has a total height of, when you add all that up, their heights add up to be 753 inches. Okay, but for the volleyball team, their heights add up, when you add all those up, to be a total of 938 inches. So the difference then between those is going to be about 185 inches. So you could say that the volleyball team is 105.80 inches taller than the gymnastics team. At the combined, we probably should this, the combined volleyball team heights. Volleyball team height is 185 inches taller than the women's gymnastics team. Okay, so that's one thing you might notice. There's a total difference, right? Now, the other thing you could look at is what we talk about as the mean. Mean is a way of saying, in statistics terms, the average. And you find the mean by taking the total number, right? The total number, 753, so for the gymnastics girls, and you divide that by the number of people we're talking about. So how many gymnastics people were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We divide it by 12, and so the mean for the gymnastics team members is 62.75. But the mean for the volleyball players, we take the total, 938, and divide it by the total number, which is 12 again, is 78.16. Okay, so that's the mean average there. It's the different is those are the mean averages. So then we could take a look at that. We could say, well, what is the difference of averages? And that would be 62.75 minus, oops, let's do the big minus little. So the difference there would be 78.16 minus 62.75, which equals, in this case here, 15.541, sorry. So that's the difference of the averages there. So another way of comparing it would be to say, well, the average height of the women's gymnastics team is 62.7, for the volleyball 78.16. And you could take your chart back up here, and we can say, well, the mean for the women is 62.75, so that's going to be somewhere about here is the mean, okay? And the mean for the men is 78.16, so somewhere about here, right? So those are our two means, okay? Now the average difference, the mean is, so we have the average difference between those two. The difference between the two averages, between here and here is 15.41. So the difference between those two heights is 15.41. That's quite a range there, right? So definitely the volleyball players on average are taller than the women's gymnastics team on average. And on average is about 15.41. You can also take a look at what is the median height. Now the median is a fancy word for which one is in the middle. So when you look at the gymnastics team, the middle value, because there's 12, we count up 1, 2, 3, 4, 5, 6. We draw a line there. These are both the same number, so the median actually happens to be 63. For volleyball, the numbers here, 1, 2, 3, 4, 5, 6, we divide it right there. So our median is actually there. So the difference of the medians is 70 minus 63 is 16. Okay? So again, that's where that is there. If you put the median in place, 63 is for the women, it's going to be right there on that line. And for the men, we're at 79, so we're going to be right there. That's the middle height. All the values are on equally in this half or that half of the line, or that part of the line there. Okay? So that's taking a look at those. All right? So this value here, this becomes, we talk about our measure of center, is talking about the mean and median. These are measures of center right here that we're looking at there. So as we're comparing how much taller one is than the other, we're using a measure of center to help figure out where that's going to be. And we look back here, these are 2 points that are in the middle or the center part of all the data, and we're comparing the two data groups compared by their measure of center. Okay? So that's the idea with that first part there. All right, now we're going to turn the page. We're going to take a look at the next activity. Okay, so for the next question it says, let's make 2 dot plots to compare the heights of tennis and badminton teams. Okay, So we have tennis and badminton. I'm going to write a T here for tennis. Make a dot plot like so. And I'm going to go ahead and go, let's see. What I'm going to do, I'm going to actually go tennis, badminton, and let's go this way. And I see for badminton I'm going 62 to 73. Here I'm going 66 to 76. So if I started with the badminton at 62, I could do 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73. So there's that, 62. I'll just count every other. And then for the tennis, we're starting at 66. Let's start here. Okay, and let's count this up here. 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76. Just to have a little kind of overlap there for how that's going to work out. Now for our dot plots, we have tennis is at 66, 67, 69. I have a 70, 71. I have two 73s, a 74, two 75s, and a 76. For badminton, I have a 62, another 62, a 65, a 66, a 68, a 71, and a 73. Okay, so there's what we have so far. So using some of the same measurements we used before, we could figure out what the mean is going to be for each of these and what the median would be as well. So the mean for the first one, we want to find the mean out for the tennis one. The mean here would be to add up all these values, 66, right? You add all that up. When you add all those together, what you come up with is 789. So if I take 789, the tennis teams, and I divide that by, in this case here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then my mean for the tennis is 71.7. I'm going to write mean right here, just so we can see how that's going to go. Okay, so that's my mean. So my mean for the tennis team is at 71.7, which is somewhere between 71 and 72. So right about here is my mean, right? There's my mean, 71.2. The mean for the badminton teams, you add those up, and when you add that up, you have 467. And we're going to divide that by 1, 2, 3, 4, 5, 6, 7. There's only 7 badminton players, and that becomes 66.7. So the mean for the badminton is 66.7, which is going to be, there's 66, 67, so that'd be right about here, right? So that's our mean. So we have a mean for both of those there. We can tell already that in terms of the measures of central tendency, measures of center, we would say that the mean of the tennis shows that the overall average heights are greater for the tennis team than they are for the badminton team, right? We can agree with that there. We can also then take a look at the median. The median is going to be the middle one. So because there's 11, I can go 5 and I can go 5 this way, 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So my median value is 73. Over here, I can go 1, 2, 3, 1, 2, 3. My median here is 66. So my median value happens to be here for the tennis, and 66 is going to be here for badminton. So even the median value, the middle value, shows you that the tennis team is going to be taller than the badminton team overall. Okay, so that's what we have so far. So the center of distribution is that. So the median is actually our center of distribution. That's the exact middle part, and so that's going to be 73 for tennis, and badminton is at 66. That's our median center of distribution, whereas the mean is essentially our kind of our average, right, or where we're going to be. Now another thing we can look at here is going to be that idea of variability, like how much do the numbers vary from each other. We'll look some more at this in just a little bit, okay? But it says, what do you notice about the dot plots? Well, we notice again that They seem to be pretty spread out overall. There's definitely some overlap happening. We can look here that the value of 66 matches up here, and we have all these overlap values happening right through there, don't we? That's a lot of overlap. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 points that overlap. There are, however, a lot more that are beyond this value, beyond the overlap, that make the average more for tennis compared to what's over there. Okay, so we can tell that the tennis team center distribution is greater than the badminton center distribution, and again, there's lots of overlap of data. Those are things we probably notice about the points there. Elena says that the members of the tennis team were taller than the badminton team. Lynn disagrees. Do you agree with either of them, and explain or show your reasoning? So Elena is saying basically that the tennis people are taller than the badminton people is what she's saying. So you have to decide if you agree with that or disagree with that. Okay, so we would probably agree with Elena, okay, because the tennis center of distribution is greater than the center of distribution than badminton. So overall, it looks like between your mean and your median that yes, the tennis tends to have taller players than badminton. Okay, and that's what we'd probably notice there. Okay, and then even your means, the difference in means. Think about your difference in means. So difference in means is what? Well, we have 71.7 and 66.7. So when you subtract that, it's a 5-inch difference just in the averages of the two different data sets. So definitely tennis is going to be taller than badminton overall. All right. So another way we can look at these things is we can look at what is called, in our case here, look at my notes one more time, make sure I get all the right words for you guys. All right. The mean absolute deviation. Okay. So the mean absolute deviation is an extra thing that you've maybe talked about before. The mean absolute deviation, otherwise abbreviated as MAD, M-A-D, okay? And the way you find the mean absolute deviation is you're going to take the data value and you're going to subtract from that the mean, and you're going to find the absolute value of that, and you'll keep doing that for all the values you have, and you'll divide it by the number of data pieces that you have to deal with. Okay, so for example, if I looked at the basketball players, I would do the data 66, and I would do 66 minus the mean, which is 71.7, but then take the absolute value of that and then add it to this one same way, this one same way. So there's a lot of data points you'd have to put together in order to find the mean absolute deviation. And it takes quite a while to do that. There are programs and statistics calculators that help you do it, but that is what happens there, okay? And we add these up, and you do another one, you add another one, do the other one, and it goes on for quite a while. And we're going to work with that on the next activity here. Okay, so let's take a look here at the family heights. Family heights, here we go. It says compare the heights of these two families and explain or show your reasoning. So the height of the Noah's family and the height of Jada's family, and their values are right there. Okay, so if we want to take a look at a couple things, we could see that if we were to make a plot point for this, and we did Noah's family, and we plot that out like so, and then we did Jada's family, and we plot that out like so. Let's see here. Let's plot this out like this. Let's use Jada's family like this. Okay. Now Noah's family is going 28 to 71. Jada's going 49 to 77. So I'm going to count by fives basically. I'm going to start here at 20 and go 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. And do the same thing here for Jada. Plot these points out. Okay, so 30, 40, 50, 60, 70, 80, and then 20, 30, 40, 50, 60, 70, and 80. All right, something like that. Now we plot out Noah's family. We have a 28, so we'll put that one right about there. We have a 39. We have a 41, which is here. We have a 52, a 63, and a 71. And we also have, for Jada's family, a 49. We have a 60. We have a 68, a 70, a 71, a 73, and a 77. Alright, so we definitely have a cluster of older height over here for Jada than we do for Noah. Noah is much more spread out there, isn't it, compared to Jada. Jada has a little cluster right there going on. Okay, so if we want to find out what the mean is, let's define the mean real quick. The mean, again, is the average. So when we add these values up for Noah, you have 360. When you add those all up, 360 divided by 1, 2, 3, 4, 5, 6, 7 is going to be equal to 51.43. When I find the total for Jada's family height, I get 468, and divide that by 1, 2, 3, 4, 5, 6, 7 as well, and we end up with 66.86. So already, just looking at their means for where they are here, the mean for Noah's family is 51.43, which again, that's somewhere, I had a 52, so it's somewhere about here for Noah's family. Jada's is 66.86, so that's going to be somewhere about here. Right, so those are my averages. And we can tell by just the averages that in terms of our measure of center of distribution, so to speak, we definitely have Jada's family is at a different point. Okay, if you look at your median, just for fun, if you want to tell what your median value was going to be, the median value in this case here, your middle one, because there's 7, we'll count 3 and find the fourth one, so 52, and the median here is 70. So the median value for this guy is 70, and this one is 52. Right there. Those are the median values, which are still showing that Jada's family is much taller than Noah's family right there. Okay, so is there an overlap of these ones? Yeah, we do have a little bit of overlap again. So I take my shortest person in Jada's family and I go all the way out to the tallest person in Noah's family, which is right there. So I do have a bit of an overlap, especially up in this range here. But Noah's family certainly has a lot more that are much, much smaller than what fit in that overlap range. And these numbers here are the ones that bring that mean value down to a lower point. That's for sure. Okay, so Jada has the greater center distribution, it has the greater mean, the greater median, and so it's just going to have an overall taller or higher, taller family people. Okay, that's what we see so far. We're going to come back to this here because the next question asks, if Jada's family adopts 2 newborn twins who are 18 inches tall, does this change your thinking? Okay, so what happens if they adopt 2 people that are 18 inches tall? Well, you come back over here, if they were to adopt 2 18-year-olds, that would be putting them here and here. Well, what's that going to do to your mean? That's definitely going to lower your mean, right? Because now, if we add those 2 people to it, we're going to do the 360 like we had before. We're going to add the 18 and add the 18, and we add those guys up together. Well, now you're at, get this right here, 468. 468, my mistake, sorry about that. This one, 468 plus 18 plus 18 gets you 504. Now we're not going to divide by 7, we'll divide by 2 more, which is 9. And now the new mean, the new average for this one becomes what? It becomes 56. Let me double check real quick. So I have 504 divided by 9 becomes an even 56. So if I was to add 2 more 18-inch people to the family, then the new average becomes 56. So where does that place it? I'll make this in green real quick for you, okay? Yeah. It's fine. So I'll go green, 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 then that places the average then about here. But again, notice that it's still going to be slightly more than Noah's, but it's definitely a lot closer to Noah's. So does that change what you think about it, who's taller or shorter? If you only had these numbers to work with, 51 and 56, you would say they're pretty close together. Yes, Jada's family is still going to be taller, but you wouldn't be quite as certain that you'd get a taller person if you picked them by randomly. Now, looking at this here as well, the other thing we see is that I also have what we call the difference of means. So the difference of means here between these two values is 66.86 minus 51.43. And when I look at the difference of means, what I see is that the difference of means between these already was 15.43. That's a pretty large difference of means that shows that indeed the family's heights, they're too far apart. So even with some smaller ones joining the family, you still have Jada's family looking to be a little bit taller than what we had with Noah's family. Okay? So that's kind of the idea right there for that one. Now, with this data set, you can also find out what the mean absolute deviation actually is for this data set. Alright, so how do you find the mean absolute deviation for this data set right here? This is a great question because it is something that I'm not sure if you learned it in 6th grade or somewhere else, but it is something that they expect you to kind of know. Okay, so when I take each of these values, and for every one of them I have to do the same thing again and again. I have to subtract, I have to take it and subtract it from 51.43. Okay, when I do that again and again and again, and then divide it by 7, then I end up with a mean absolute deviation, okay, for Noah's family. Alright, so Noah's family has a mean average, well, let's just show you how to do this real quick. To make this work, what I'm going to do is show you here. Here's Noah's family, okay? So for Noah's family, what we do, again, using our value here, we're going to do 28 minus 51.4, and I can do 4.3, but I'm going to do that one. I do the absolute value of that plus absolute value of the next value, 39 minus 51.4 plus the absolute value of 41 minus 51.4 plus the absolute value of 52 minus 51.4 plus the absolute value of 63 minus 51.4 plus the absolute value of 66 minus 51.4 plus the absolute value of 71 minus 51.4, and all of that, got all that there on the screen, oh my goodness, because I have to count the number of values, I'll take all that and divide all that mess by the number of values there are, which were 1, 2, 3, 4, 5, 6, 7. Okay, so when I do that, what I end up with is this. These numbers here, and I'm not going to show you right now, I already did it ahead of time, those all combined, the sum of all of this, the sum of all of this is going to be 92.6 still divided by 7. Okay, and again, you get that by doing, I can look at this first one, 51.4. I know it says 28. You can do 28. You could do 28 minus 51.4, and I get negative 23.4. But it's the absolute value, so I really have 23.4, don't I? Okay, and so I end up with 23.4, and I just add all those up, and when I add all those values up, I get 92.6 minus 7. So what is this? What is this number is? This is how far away the number is from the average. So 28 as a value here is how far away from the average point. Well, here's 28 right there. The average is here. So this value is telling you the distance from here to here. Remember, absolute value tells you distance. So the distance from here to here is 23.4. So what we're finding is the average distance, the distance between all the points from where they are to the line. You add all those up, and those distance values we're dividing by how many points there are. So 92.6 divided by 6 actually equals 13.22. So the average distance each point is from the mean. That's what this is. This is the average distance each point is from the mean. 13.22 segments away. Okay? That's the average distance that it is away from the mean. And you could figure that out. You know, you could do another color if you chose to, whatever. You know, we could take it and say, well, the mean's there. We're doing 13.22. Well, that's a range from somewhere about here, and we're going to go 13 this way and 13 this way. And so if you think about it, this was at 51. We go down 41 and then go down to about 38. So we're going to go somewhere from here to here, and then go up from 51 to 61 and a couple more, so 64, up to about there. So the average distance is somewhere in there for Noah. Now we take a look at Jada, right? That's Noah's values. Jada's value is the same thing. Again, you're going to do 49 minus her mean, which was 66.8. Okay, and we add that to 60 minus 66.8. Add that to 68 minus 66.8. Add that to 70 minus 66.8. Add that to 71 minus 66.8. Add that to 73, absolute value, minus 66.8. And add that to the absolute value of 77 minus 66.8. All of that, once you find that sum, will also divide by 7. This is Noah, this is Jada. Okay, oops, sorry, a little off the screen there. So much stuff, okay? Now when I add that sum together, what I come up with then, when I add that up, is actually 49.6. So 49.6 divided by 7 is actually equal to 7.09. So that tells me that for this next one, oops, lost my pen. If I take the average for Jada's family, the average for Jada's family was 66, we said, which was here the yellow. I need to go left or right about 7. Okay, so if I go here 7, it's going to go about there. And if I go here 7, I'm at 66. I'm going to go up about 73. I'll go about here, which means that that's the average distance for the points in on our plot. Okay, so now that's the mean absolute deviation for each one of these data sets. But what I really want to find, though, is the overall mean absolute deviation. And to do that, what I'm going to do is I take the difference in means, I divide it by the larger mean absolute deviation of the two groups. Or if there's more than one group, it's fine too. And that's going to give me my overall mean absolute deviation. So in this case here, the difference of means, I look back over here, what was the difference of means? Look back at my notes. We said 66.86. Oops, get on there. 66.86 minus 51.43. So the difference of means was 15.43. And I divide that by the larger absolute value, absolute deviation mean here. The larger one, I have 13.22 and 7.09. Which one's larger? 13.22. So I divide it by 13.22, and when I divide 15.43 divided by 13.22, I end up with 1.16. Okay? So what this tells me then is that that's a small difference there. Okay? That's my standard here. It's not very large, not a big difference. But what that's going to tell me is that overall, there's not a huge difference that's going to be made by just adding a couple more points. Okay, if it happens to be greater than 2, if your mean absolute deviation is greater than 2, it's going to have a significant difference on what happens when you change your data points. But because it's less than 2, adding a data point didn't change anything, which is what we saw. Adding 2 really short people to Jada's family, yes, it had a change in the mean, but they were still overall taller than Noah's family. So Yeah, you could add some more data points and even some high numbers or low numbers, but overall, because you're looking at a 1.16 MAD, you're not going to have a significant change. Okay, so let's take a look at the next one here, which is, again, another optional activity that you may or may not do, but may be good to have in your notes for later on. Okay, so here's what we have. We have some 3-dot point plots that represent the lengths in minutes of songs on different albums. You have 5-minute songs here to 6-minute songs. These songs are really short, half a second, all up to 5 minutes. And here's a cluster from 3.5 minutes to 4.5 minutes. One of these data sets has a mean of 5.57, another has a mean of 3.91. So again, mean is looking at kind of a central tendency, what's kind of in the middle of all these things happening here, which one makes the most sense because it belongs sort of in the middle. So which one of these looks like it might have an average of about 5.57? Well, looking at what we have, this is in the 5 range here, 5 to 6. This is spread out everywhere, and this is in the 3.5 to 4.5 range. So based on what I see here, this one seems to match A with probably an average about 5.7, right? Somewhere about here is about average. Looks about right. And the 3.91 looks like it'd go right about here for this one, for choice C. So I would say this is showing plots A and C. So what's the mean for plot B? Well, plot B, our mean there, we need to add up those points, okay? So what do? We take our 0.5, we have a 0.5, we have a 0.75, we have a 1.5, another 1.5, a 2.0 if you want, a 3.75, a 4.25, and a 5, and we add those up, and when we add all those values up right there, what do we end up with? Well, this sums up to be 19.25, but I'm not done, that's just the total. I want to find the average or the mean, so I have to divide by 1, 2, 3, 4, 5, 6, 7, 8. So I divide that by 8. So I do 19.25 divided by 8, which equals 2.41. So the mean for this data set is 2.41. This one was 5.57, and this one was 3.91. I'm going to plot the 2.41 right now. I'm thinking about it. It's about here. Now so far I've been doing it in yellow. Let's just stay consistent there. So there's the average for this one, there's the average for this one, and there's the average for this one. Okay, so right about there for those guys, right there. All right. Now, number 2, this is the little one, we kind of go back to your notes here. One of these data sets has a mean absolute deviation of 0.30, and another has a mean absolute deviation of 0.44. Okay, so the mean absolute deviation, this is where it's a little trickier, right? This is going to be that average distance away from the yellow line is 0.3, and the average distance away is about 0.4. So you want to look at basically kind of where are things bundled up at? Where do you have things close together at? Okay, so being a 0.3, this is definitely closer, smaller. So think of it this way. Sorry. If I had a yellow line, this is my numbers, and I had a yellow line like this, what we're saying with 0.3 is we're saying that the points are about 0.3 this way and 0.3 this way from that line. Where this one's 0.44, so the points are a little bit further away from the yellow line. So looking up here, where do you think the bubbles or the dots are closest to the yellow line altogether? I'd probably say this shows me the being the closest right there. So I would say that graph C has the mean absolute deviation of 0.30, because that seems to be the closest little spread there. Whereas the 0.44, being about 0.4 away, again that's about half, looks more like A. So 0.44. If you were to plot these, what you're talking about is just saying that, again, 0.3 is like taking a line from the mean out this way and out this way, and are most of the dots somewhere in that range? They're pretty close, aren't they? For the 0.44, you're going out a little bit more, right? This is about 0.44. Each one's about a half, so you're going about this way to this way. Are you capturing most of the points in that little window of space there? It sure does look like it, aren't you? Okay. So knowing that's the case, okay, again, the mean absolute deviation is on average, how far away a number is from the mean of the data set. So on average, how far away it is. So the next question it asks you, of course, is calculate the MAD for B. So to calculate that, what we want to do is we're going to take these values and we're going to subtract them from the mean. 2.41 minus 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 2.41. But of course we take the absolute value of each one, right? So I won't have a negative number, I want the absolute value. So when I do that, let's put equal signs here. When I do those there, when I do the what is 2.41 minus 0.5, I end up with 1.91. 2.41 minus 0.75 is 1.66. 2.41 minus 1.5 is 0.91. 2.41 minus 1.5 is still 0.91. 2.41 minus 2 is 0.41. 3.75 minus 2.41 is going to be 1.34. And then this one is 1.84. And then finally we end up with 2.59. Oops, 59. When I add all those up, when I add this up here, which is my absolute value of the data minus the mean, okay, I end up with 11.57. I'm going to take that value, remember, I take that value and I divide it by what? I divide it by the number of items in the set. 1, 2, 3, 4, 5, 6, 7, 8. And 11.57 divided by 8 equals 1.44. So my mean absolute, my mean absolute deviation for this one is 1.44. Right? This one we said was A was 0.44. This was 0.3. So 1.44. So what does that mean? That again means that on average, the points are about 1.4 away from the mean line. So we're at 2.5, we're going to go up to 3.5 and a half more. We're going to go 2.5 to 1.5 and a bit more. So on average, that's the spread of those numbers, right? They're in that kind of bandwidth there. Pretty large. So that's pretty large compared to these other ones, much, much smaller. So you can see the range of numbers are within a really small band, a little bit bigger, and really big because it's really stretched out data points there. That's what your mean absolute deviation is explaining there and how that actually works. Okay, so we answered this one here. We said it was 1.44. Do you think the three groups are very different or not? Be prepared to explain your reasoning. Well, it's hard to say. So how different they actually are. Okay. With B, because there's such a spread happening with B, it's hard to say that it's very different because it's just unusual. Okay, is it very different? It has a little bit of everything, but it's spread apart. So is it different? Definitely doesn't match the other ones. Now, in terms of A and B, that's right, or the A and B. Okay, or A and C. A and C have smaller mean absolute deviation, but because of that, you can see that they're much more tightly around that 4-minute mark or that almost 6-minute mark there. So there's a big difference there. They're very clearly different albums. This one, there's no real pattern with it. It just kind of has a little bit of everything. But these are different. This is overall, you expect to have about a 5.5-minute song. Here you expect about a 4-minute song. So those are different there and how that works out. It says a fourth album has a mean length of 8 minutes. with a mean absolute deviation of 1.2. Is this data very different? Well, we would definitely say yes, but why yes? I think the key thing there is that mean. That mean is 8. That's greater than all the other means, isn't it? All the other means are much, much smaller than that. We had means that were 5.5, 2.4, and 3.9. 8 is much greater. So you're going to find that that album is going to have a lot more long songs compared to all the others. Okay, so that's a lot of information I know. Oh my goodness, that only took me a zillion hours. So comparing two individuals is very straightforward. The question which dog is taller can be answered by measuring the heights of two dogs and comparing them directly. Comparing two groups can be more challenging, right? What does it mean for the basketball team to generally be taller than the soccer team? What does that actually mean? So to compare two groups, we use the distribution of values for two groups. Most importantly, we have a measure of center, which is the mean or median, and its associated measure of variability. So a measure of center, and we also have the measure of variability, which we usually use the mean absolute deviation, or sometimes you talk about the interquartile range, which we didn't talk about today. And that'll help you determine the differences between groups. Okay, so we're going to pause there and let you work on your homework, and then we'll come back and check it together. All right, homework time. First one says simply to compare the weights of backpacks for the students in these three classes. All right, so to do that here, there are things you could find. You could find the mean for each one. You could also find the middle, the median for each one if you wanted to, and compare how that ranks. You could also just use the data points to make some notes about what do you see happening. So for example, I have 7th grade. In 7th grade, it seems to be that there's a lot of backpacks that are kind of in this range here and just a little bit in that little bandwidth. So most kids have a backpack that weighs about 10 pounds in 7th grade. In the 9th grade, I can have a high point here, but that seems to be about the middle as well of the data point. So 9th grade backpacks on average seem to weigh somewhere about 18 pounds. 11th grade is much more spread. The middle is still here at about 18, right? That's about the middle of the point, but we definitely have a wider range of backpack weights in the 11th grade. So what are some things you could say? You could say 7th grade backpacks tend to weigh less than 9th and 11th grade backpacks, okay? You could say there's less of variability in 7th grade, right? They're much more the same, right? 8 to 12, very much a small, tight range, whereas the 9th and 11th grade has a broader range of weights, right? That distance or the difference between your highs and lows is quite different. There's a range of options there. So 7th grade is about 10 pounds, 9th grade about 18, and 11th grade might average 18, but it definitely has a wide range there, okay? And then 11th grade just has, yeah, that's where we are. So that's the big thing. So your distance of central, here the distance is centered around 18 and 10 there. So just write some stuff down on what you think is going to work there. And actually, that's the only question we have today related to today's lesson, which was super duper long, but that's because you had to probably work a lot of stuff. It'll come up later, I'm hoping. Number 2 is review. Bookstores marked down, price going down. The price for all books in a series by 15%. What is the discount? Going down on a book that normally costs $18. So, a 15% of $18 is what we're trying to find out. 15% as a decimal is, move it over 2 spaces, is 0.15 of means times, and times 18 is going to give me 2.770. So the discount is $2.17. So how much would the book cost? Well, we'll do $18 as the original price minus what it cost, and in doing that we come up with $15.30. Alright, let's turn the page and look at the next one. We have a list once again, trying to put together some expressions and equations, so I'll do a couple of them with you. The first one, let's go ahead and distribute this out. We have 6 times x, which is 6x, 6 times 2y, which becomes 12y, and then we have minus 2 times y becomes minus 2y, and minus 2 times minus 2x becomes plus 4x. I don't see that over here. It looks like we're doing some factoring here. So let's combine some stuff. I have 6x and 4x, that becomes 10x. 12y minus 2y becomes minus or plus 10y. I don't see that there yet, but I do see factored out 10, so let's factor 10 out. When I do that, I have 10 times x plus y. Alright, x plus y, yep, I see that there. So the first one is going to match the second one right there. Okay, notice that there are 5 things here and 4 answers, so one of the answers will be repeated twice, so keep that in mind. Alrighty, if I look at this, let's look at D real quick. 4 times 5 is 20x, 4 times negative 3 is minus 12y, and then I have minus 10x plus 6y. Combining things, 20x and minus 10x becomes a positive 10x, minus 12 plus 6 becomes a minus 6y, and I can see that one looking me right in the eye right there. So make sure you do the same thing for B, C, and E. And finally, angles C and D are complementary. Complementary means what? It means they add up to be a right angle, 90 degrees. That means C plus D equal 90 degrees. Okay. The ratio of the measure of angle C to angle D is 2 to 3. So C is 2 and D is 3. Right? It'd be like saying 2 plus 3 equals 5. But in this case here, it's not going to equal 5, it's something else. We know 2 times some value plus 3 times the same value, because it's a ratio, is going to add up to be 90, because that is complementary. So 2x plus 3x is 5x equals 90. Divide both sides by 5, and the x now equals 18. So to find the value of C, we have to plug x into our equation. Well, C was times 2. So we do, 2 times x, and x was 18. So 2 times 18, which is 36 degrees. For D, D is 3 times x, so 3 times 18, which is 54 degrees. And that's it for today. Have a great day. We will see you next time.